Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. Now, take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Tenacity 2 by Chinstrap, and this is, I believe, his second Tenacity puzzle here. Anyways, here are the rules. Normal Sudoku rules apply, which means fill every row, column, and box with the digits 1 through 9 without repeats. We also have tentropy lines, where every set of 4 adjacent digits on a peach line must contain a digit from each of the X pairs or 10 pair subsets of 1, 9, 2 or 8, 3 or 7, and 4 or 6. A 5 may not appear on a tentropy line, and digits on the line may repeat if allowed by other rules. So, as an example, for these 4 cells, since they are adjacent on a tentropy line, a valid example here could be something along the lines of like 3, 6, 2, and 1, right? Because we have one digit from each of the subsets that add up to 10, which is 1, 9, 2, 8, 3, 7, and 4, 6. So this is part of 1, 9, this is part of 2, 8, this is part of 4, 6, and this is part of 3, 7. And a 5 can never appear on a tentropy line. And that's how tentropy lines work. We also have the rule set little killers, where numbers outside the grid are the sum of the digits pointed to along the indicated diagonal. Digits are allowed to repeat along these diagonals as normally allowed by the other rules. So, for example, these 4 digits must add up to 21 because they are pointed to by the arrow and the 21 connected to it. These 4 digits must add up to 24, these 4 must add up to 22, and these 4 must add up to 23. So as an example, this could be something along the lines of, I don't know, 6, 6, 5, and... Oh, I guess it would have to be 5, if that's the case. This is a valid little killer solution here, because they all add up to 22. And they only have repeats in the correct places, because this 6 does not see this 6 anyway, right? It's not in the same row, column, or box. And this 5 doesn't see this 5 because they're not in the same row, column, or box. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so a tentropy line can never have a 5 on it. So where's the 5 in box 1? It must be... I guess let's color it pink. Do we color it pink? I don't know. That make things confusing. Let's just make it 5. What about box 2? It has to be here. What in box 3? It has to be one of these 2 cells. Because it can't be here because of that 5. Can't be here because of that one of those is a 5. So this has to be one of those is a 5. Same, this is basically symmetric around, rotationally around the center. So these also must be 5 then. These can only be 5, and these can only be 5. Well, what about boxes 4 and 6? These are tentropy lines, so 5 cannot be there. So 5 has to be one of these 3. Same here, 5 has to be one of these 3. That eliminates 5 in the rest of the column, so this can't be 5, and this can't be 5. Well, we know where the 5s have to be in box 1 and box 7. They have to be here and here. Similarly, these 5s eliminate this from being a 5 and this from being a 5. So we know in boxes 3 and 9, the 5s have to be here. Okay. What else do we know? Let's just start coloring this outer ring randomly. I'm going to make this red, green, pink, and blue. So this has to be a blue because we already have pink, green, and red in that set of 4. This then must be pink. This is green. So every 4th set is the same set. Every 4th cell along the line is the same set. So then these are all green. These are all red. And these are all blue. Therefore, these are all pink. Okay, what does that tell us? I'm not sure. What that tells us is these 2 digits cannot be pink. So one of these digits has to be a pink. So this is green. Also, this digit specifically cannot be blue. So this is either green or red here. Because it can't be blue, because we have 2 blues already, and that takes up all the digits in that subset. We have pink, 2 pinks already, and that takes up all the pinks in that subset. So this is green or red, which means this must be green or red. This digit cannot be pink, so it's green, red, or blue. Which makes this green, red, or blue. Interesting. Pink could be either of these 2. So the remaining digits in column 2 have to be green, red, or pink. So this is green, red, or pink. This is green, red, or pink. Let's see. Oh, similarly, this can't be red because we have 2 reds here, and this can't be green because we have 2 greens here. This color has to be green, red, or blue. We're not sure which, though. This can't be green or red, so this is blue or pink. Therefore, this is blue or pink. This has to be blue, pink, or red. This also has to be blue, pink, or red. This cannot be red, so it's green, pink, or blue, which means this is green, pink, or blue. And this could be all 4. Well, in this set of 4, we know we have a green and a red. So this cannot be green or red. So this is either blue or pink here. Similarly, we have a blue and a pink here, so this has to be green or red here. Does that tell us anything? I'm not sure. This is the same as this. That doesn't really tell us much. Oh, interesting. Okay. One thing we know is whatever this color is, whether it's green, red, or blue, we already have the other part of the set in one of these three cells. So it cannot be in any of these three cells, which means that that set has to be in both of these cells here. And it can't be red, obviously. So this must be specifically green or blue, which makes this also green or blue. So this has to be green or blue specifically. Both of these are green or blue. And then we have a similar thing here, right? Whatever is in this cell, whether it's blue, green, or pink, the second part of the set is here. So this can never be green, pink, or blue, which means whatever this set is. So that set has to be these two sets, or these two cells, which means it can't be pink, so this can't be pink then. This is green or blue also. They cannot be the same set, right? But we do know that this then has to be red or pink, because one of these is the green or blue set. This is the other one. Therefore, this must alternate green, blue, green, blue, green, blue, green, blue, right? Therefore, these are red and pink. That's actually very cool. Interesting way of working. So therefore, we have all of these are blue and green, right? All the blue and greens are already taken care of. Um, this is the same as that and that. Well, we know red can't be any of these. One of a pink is here, so the other pink has to be here with a 5. Same here. This is pink, and one of these has to be pink, so this must be then red as a leftover. Well, okay. This pink, we know one of these four is a pink, and this is a pink, so this can never be pink. So it has to be blue or red here. Similarly, this is red, and we know one of these four is a red, so this can't be red here, because we have two reds then in row 9. What else do we have? This has to be blue, pink, or green. Okay, we know this can't be red anymore. Where is the red in column 2? It's here, and then one of these two has to be a red. Therefore, these can't be red, because we know one of these two has to be a red. And then this, oh wait, they could be red. Never mind. Right. We know one of the reds is here, shall we say. So if this is red, this would have to be red. If this is red, this would have to be red. So one of these is red, and the other one has to be green. But that doesn't really tell us too much. Okay. Where are the blues in column 3? One of them is here, but none of these can be blue. This can't be blue because it's not 3 away from blue. This one can't be blue because this one can't be blue. So one of these has to be a blue because we only counted for one in the column. And the last one has to be here. This is a blue, therefore this cannot be blue. The rest of this column cannot be a blue. So one of these is a blue, therefore. We have a green or pink here, a green or pink here. One of these is a blue, similarly, I think. Maybe not. It's kind of different. We should have something similar along this end, right? One of the greens is here. This can't be green. One of the greens then must be in one of these two cells, which means this is green. One of these is green, so this cannot be green here. So this is blue or red. This is blue or red. Hmm. What does this mean? I'm not really sure. Here along this line is green, pink, or pink and 5. This we don't know. Hmm. Excuse me. Hmm. So one of these is blue. That's fine. Okay. Well, this is blue. This can't be blue. None of these others could be blue. So blue has to be one of these two, which means one of these two is a blue. So this can never be blue. That's actually kind of interesting. Similarly, um, one of these is green because this can't be green anymore. So one of these two must be green, which means this can't be green, right? This can't be green either because one of these two must be green. So this is blue, red, and pink as a possibility. Interesting. Okay. This then cannot be, what is it? Cannot be blue because one of these two is blue. So this is pink, red, or green. Which means we know green has to be one of these two. And then green is here. Okay. What, for box one, what are the possibilities? If, well, blue has to be one of these two. Green has to be one of those two, which means green is one of those two. So if green is here, that's green. That forces this to be red, and that's red. This has to be blue and blue. This is pink. Okay, so let's mark that down as pink there. Right? If this is green, this is green. These both have to be red because those are the only things left. Because then that would be pink. So green, green forces this to be blue, which makes that blue. This has to be red, and this has to be pink. If this is red and red, that means green has to be here, and green is here. This red means this is pink. And this is green. So we have green, green here. And this would be blue. Okay, so this is the equivalent then of this not being pink, right? Say this was pink, then this would be blue, blue. Uh, right, this matches this. Therefore, this can't be pink. That's why. This is green or red. One of the greens has to be here. This is one green. Interesting. Okay. One of these is green. Only one of these can be green. And so therefore one of these is green too, which means none of these can be green. So it's blue, red, and pink. Um, this can't be pink though, because one of these two is pink, and one of these two is pink. So this is blue or red. This has to be then green or pink. This must then be blue, red, or green. Hmm. Okay. Well, actually, we do have a lot of information now. Only one of these can be green, because you can only have one green along this set of four. This can't be green. We need a green in one of these three cells. But again, that can't be green because both of these are green. This can't be green because one of these has to be green, and one of these has to be green. So therefore, there's one green here too. So green's here, which means a green's here, which means this can never be green. Hence, this must be a green. So this has to be green, which means equivalently, this has to be blue, right? Because none of these could be blue. Only one of the blues can be here. Okay. Hmm. Only one of the greens can be here. Only one of the pinks can be here also. Which means these have to be opposite colors, whichever they are. Same here. These have to be opposite colors. But that's only for these, right? So we'll label them, I don't know, A and B. And this will be C and D. We know these have to be opposite colors. These, I think, also have to be opposite colors. But these do not necessarily have to. Say this is green, right? If this is green, that means this has to be a pink, which makes this a red, which forces that to be red, which means this is green and green. So again, if this is green, this has to be pink, which makes this red and red, which makes that green and green. So then this would be pink and pink. That works. If this is pink, that means this is green, this is green, this has to be red. This green means this is blue. This is red and red. So this pink would then force this to be green. right? I think it's green either way then. If this, okay, so if this is pink, again, if this is green, this then becomes red, which forces this to be red. This is pink. This has to be green because we have two reds, and this is green then. Because, yeah, green has to be one of these two. So therefore, this must be pink, if that's the case. So again, if this is green, that makes this red, red. Pink, this is green. Hold up, okay. Okay. If this is green, that makes this red, because we have two greens already in the column. This is red, therefore this must be red to match. We have two reds now, which makes that green. We need one of these two to be green, so this has to be green. That's green, green, which makes that pink, right? So we know that that would be pink if that's the case. If this is pink here, that means this is red, which forces both of these to be green. This is red, this has to be blue, and this is pink. But this pink means this cannot be pink here. This has to be green. But we don't know what that is. It could be many things. Okay, so it's still, I mean, it could be the other green. So it could be pink or green there. So we don't have a restriction there. Oh, well, no, never mind. Well, say actually this was pink and no, that's not helpful. Where's the 5 here? Can this actually be 5 in the corner? Can there be a 5 in the middle? Maybe, actually. Um... Remember, these two are the same set. These two are different sets. Uh, hmm. Yeah, I don't know how easy I would consider this. This doesn't seem to be easy, per se. Hmm. Hmm. Well, we know one of these is a red, but that's not very helpful. Um, so either this is red, which forces both of these to be red. Okay, so what happens if these are red? If these are red, that means this can't be red. It's a 5. This has to be a red. And we need 2 reds here, so it would have to be red and red. I mean, that seems possible. Um, that also means these two are pink, which means this is not a pink. It has to be 5. Okay. Hmm. 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 Okay. One of these two is a pink. We're not sure which. One of these two is a pink. And then one of these two is a pink. Hmm. These are opposite colors. These are opposite colors. These are the same. These are the same. These are the same. These are the same. Okay, in row 4, we only have so these are the same. Okay, let's mark them, I guess, E and E. These are the same. F and F, G and G. H and H. Oops. H and H. What does that mean? I don't really know. Hmm. 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 Not seeing where to go with this, actually. Um, this is also G, right? So this is G, this is H, this is F, these are E. So one of E has to be here, one of these two cells. So one of those has to be E. The other E, oh, this can't, okay. Well, we already, yeah, okay. I've just completely missed this. This is green, blue and blue, so therefore this can't be blue. Therefore it must be green, which means this is a green. Since this is green, this can't be green. This has to be red. This can't be green. This has to be blue. Ugh, I don't know how I missed this. This can't be blue then, because they're different ones. These have to be green, which makes this blue, which means this can't be blue. This is green. So this is green, this is green. This is red, so this can't be red here. This must be pink, which means neither of these are pink. Therefore, it must be blue and blue. This can't be blue. This has to be pink. We have all the sets here. This is green and green. This can't be green. Which means this is blue, which means this can't be green. This is blue. This can't be blue. It must be pink, which means this can't be pink. This has to be red, which means these can't be red. These are both green, which means this can't be green. This green means this can't be green. This must be pink. Therefore, since this is pink, this can't be pink anymore because we have two pinks. This must be green. Okay, we delete the outer stuff. Remove that. This is pink. This is pink. So this is blue and blue, pink, green. This is blue and blue, which means this can't be blue, so this must be red. That means this can't be red. This is red and blue. We have two blues here, therefore this can't be blue. This has to be red, which means this can't be red. Similarly, this can't be green because we have two greens in the same row. This is pink and pink. Therefore, this is red or green, and this is red or green. This is blue or pink. But we have two blues already. This can't be blue then. This can't be blue. This can't be pink. So this is blue, 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 blue. We have two pinks here. Therefore, this can't be pink. So all the G's are not pink, and therefore red. The reds, all the H's are not red. They're pink. Which means we have two pinks here, which means this can't be pink, which makes that a 5. So this can't be 5 anymore. This cannot, this also has to be a 5 because we have two reds in the same column. Which means this is not a red. This is a red here. We have red, red. We have two greens here in this column, so this can't be green, which means this can't be red. So we have green, green. Let's see. The remaining digits here are both pinks, and neither of these can be pink. So this is pink, pink, and we need a blue. So this is a blue. Same here. We need two reds, and this can't be red because these two are red. So these both must be red, and we need a green left. So the remaining digits are blue and green and a 5, but we don't know where those are. So blue could be either of these, green could be either of these, and then the 5 could be any of them. Here we have green and pink. Well, that's kind of limiting, right? Can't be blue or red because we have two blues and reds. There have to be green and pink left, and these can't be green or pink here. So this has to be a 5, which makes this green or pink. We have two pinks here. This has to be green, which makes this a pink. Similarly here, we need blue and red. But blue and red can't be here because both blues are already in the row and both reds are in the row. So this must be a 5, which makes this a blue. And this has to be a red. Well, these can't be 5 anymore. Whoops. These can't be 5 anymore. So this must be a 5, which means this is not a color. These are both blues. Okay. Yeah, I missed this one. I don't know why. Anyways, that makes things a little easier. We have... Okay, this is different from that cell, which is different from that one. So these two must add up. Okay, this is different from that, which is different from that. So these two must be the same. This is different from that, so these two must add up to 10. So this is a 6. What about these? This red... This must be similar here, right? This green is different from this green, which is different from this one. So these two are the same. This is different from that, so these add up to 10. Therefore, this must be 8. Right? Because we have a 5 and we have 10. 15, 23 minus 15 is 8. So this is 8, which makes this a 2. This 6 makes that a 4. So this can't be 4. This is 6. This is 4. This is 4. This is 6. This has to be a 4, which makes that a 6, which makes that 4, which makes that 6, 4, 6. This 4 means this is a 6, which makes that a 4, which makes that 6, which makes that 4. That makes this a 4, and this must be a 6. So that should have all of them. We have 2 and 8. This is 8, which makes this 2, which makes this 8. Oh, this adds up to 24. This is 10 already. This is 5, so this must be 9. But anyways, we have 2 and 8. That makes this 8, which makes that 2, which makes that 8, which makes that 2, which makes that 8. 2, 8, 2, 8, 2, 8, 2. This is an 8, this is a 2. This is 9, which makes that 1, which makes that 9, 1, 9, 1, 9, 1, 9, 1, 9, 1. 1, oops, 1, 9, 1, 9. This is a 9 because of that 1, so this is a 1. And then this is already 2 and 5, 2 and 8, which is 10, plus 5 is 15, so this is a 7, which makes that 3. This 7 makes this 3, which makes that 7. 3, 7, 3, 7, 3, 7. This is a 7 because of this 3, which makes that 3, 7, 3, 7, 3, 7, and 3 in the corner. I don't know if I would consider this easy. It's a lot of things to spot out. I would consider this more a challenging level puzzle. Yeah. Very cool concept, though. I like the idea of it, particularly because of the sets which we got from it. Particularly, this was very interesting, this one, which eliminated the green from being here, right? Pretty cool concept. I enjoyed the solve, and I hope you enjoyed the solve, and I'll see you next time on Frank Puzzles. Take care.